welcome to the Optics and Lighting session. And I will be your moderator for this session. I am Supratik Banerjee from the VDMA. And for the first topic we have is about image quality, protection, repeatability, why filters are a necessity. Our first speaker, please welcome from Midwest Optical System, Georgie Das. The floor is yours.
Thank you. All right, well, good morning, and thank you so much for having me. My name is Georgie Das with Midwest Optical Systems. We've been around for about 30 years, manufacturing optical filters and custom optics. We're located right outside Chicago, Illinois in the US. And again, it's great to be here. Today I want to be talking about optical filters and how they can help with image quality, protection, repeatability, why filters are a necessity. Oftentimes, if you are familiar with optical filters, it's not something that we consider essential. When you're designing an application, you might get your camera, your lighting, your lens all ready to go. And if there's a problem, you might consider an optical filter to help with your application, to solve some problem. But my goal is today, this morning, in the next 15 minutes or so, to show you that optical filters are very essential, and they are a necessity, not just an accessory. Filters are essential for lots of different things. Very briefly, we'll look at a few different things and how they can help in your different application. We'll look how they can help with contrast, resolution, repeatability, how they can help reduce glare when your inspection process, how they can help with color correction, and also one thing that's growing in popularity and trending is how they can help with protection in different environments. So let's take a look at how filters, specifically we're talking about bandpass filters in this example, how they can help you increase contrast. In machine vision, contrast is the name of the game. You're trying to create some separation from one part or another, or trying to read some text from the background. And bandpass filters can really help create that contrast, especially when you're dealing with a monochrome type system. Here in this example, I have my color image with the red and blue bottle caps. You can see there's plenty of contrast there, easy to tell the red and the blue apart. But what if I have a monochrome system, all right, a grayscale system? It's more difficult to tell the red and the blue from each other. So if you had a simple color sorting application, maybe you don't need a color camera, maybe you could use a monochrome system with the help of bandpass filters. In the top image, I'm using a red bandpass filter that's passing red wavelengths and blocking blue wavelengths. When I pass a wavelength in a monochrome system, it becomes highlighted. When I block it, it becomes darkened. So in that top image, I'm using that red bandpass filter, passing red wavelengths, allows me to highlight the red bottle caps and block the blue ones so they appear darkened, easily creating contrast. Very similarly, in the bottom image, I'm using a blue bandpass filter to pass blue wavelengths and block red ones. So very easily creating contrast in a monochrome system with some bandpass filters. Bandpass filters can also help to increase resolution in your lenses. There's a type of distortion that occurs in lenses called chromatic aberration. This happens when different wavelengths are trying to the lens tries to focus them at the same point because different colors or different wavelengths have different refractive indexes. They bend a little differently. But if you're looking at an application where maybe you don't care about all the colors, you want to limit the number of incoming wavelengths, you can use a bandpass filter to filter any information or wavelengths that you don't necessarily care about. This actually helps to improve that aberration that happens. And you can see from the first image to the second image how the resolution increases. And so this is something that can help. Moving on from bandpass filters, short pass filters are also called IR cut or infrared cut filters. This can help pass shorter wavelengths and help to achieve a natural color rendition. In that first image, we had a customer who set up several cameras around a football stadium, an American football stadium, and this particular camera didn't have any IR cut filters, and so there was a weird pink reddish hue on the final image. Obviously, our eyes weren't picking it up, but the camera was. what was happening was the stadium lights, the sun was giving off a lot of infrared that the camera was very sensitive to, and causing that pinkish hue in there. And so using a short pass filter to block those interfering infrared wavelengths, we were able to produce a natural color image that our human eyes are used to. So short pass filters or IR cut filters are another great way that filters can help in your applications. Another popular type of filter is a polarizer. Polarizers help to reduce reflections and specular glare. So if you have an inspection process or an application that is looking at something that is very shiny and it's hard to read, polarizers can help. And they're all useful in visible and infrared applications, and lots of different options in terms of contrast ratio, the materials they're made out of, and so they can help and are very customizable in lots of different applications. Now, you might be familiar with the polarizing filter, something that you add to your lens, to your camera lens, that you can rotate to help remove that specular glare. But the important thing to keep in mind when using polarizers, and if you have a light source that you're using for inspection, is that you want to polarize both your light source and your lens. Just polarizing your lens is not going to be as helpful as polarizing both. Let's take a look at this application. We had a customer who was inspecting some beer bottles. The label was very shiny and very difficult to read and see the alignment of. So you can see the first image that has no filter. You can see that it's very shiny, it's very difficult to read. Then we add a polarizing filter to the lens, and you can see that there's not much difference. But in the third image, when we add that polarizing filter to the lens and to the light source, you can see the drastic reduction in glare. And then in the final image, we use a red bandpass filter in addition to the polarizing filter and the film to just get rid of some overhead interfering light. And so you can see how polarizers can really affect and help with the applications that are dealing with specular glare. One of the things that we really appreciate about filters is how they can help improve repeatability. We refer to filters in MidOpt as an inexpensive insurance policy because they help to ensure that you're able to repeat your application. And what I mean by this is oftentimes when we're setting up an application, we're doing it in a room that looks like that first image. It might be difficult to see. It's a lab kind of condition. Lighting conditions are ideal. There's no windows. There's no people walking around. You set up your application, and it's working great. But then what happens? Well, you move your application to the customer site or the factory floor, and now all of a sudden you're getting read errors or you're having issues that you weren't having in your lab. Well, that's because you've introduced a whole lot of light that you weren't aware of. There's skylights, there's windows, there's people walking around. I can't tell you the number of times that we get calls saying, hey, my application works fine, but every day at 12 o'clock, the application stops working. Well, the sun is going overhead on a skylight and just lots of interfering sunlight causing read errors. Now, what's the solution? Well, you can create some kind of system that would cover to block that ambient light out, but that takes a lot of space, it takes a lot of money. But you can also use a filter. A filter is controlling what light is entering the system and only passing the light that you're intending to pass and blocking any interfering light. You're essentially shrouding your application, but instead of building an entire shroud around it, you're using a little filter that goes on at the end of your lens. So again, a very inexpensive way to ensure that your application is going to work regardless of the environment that you put your application in. One of the last things that we'll talk about this morning is protection. Now, as embedded systems become more and more popular, they're being deployed to lots of different environments. Sometimes they're harsh environments. Protection is becoming very essential. You want to protect your lens, your camera, your whole setup. And so using filters, optical windows to ensure that your system is protected becomes very essential. Now, obviously, there's different types of materials that you can use, but one of the more popular ones in the recent months and years has become acrylic. Now, when you're selecting acrylic, you want to make sure that it's an optical grade acrylic material because you are imaging through this window. They're available with lots of different coatings that can make the protection window even more robust than just a simple protection window. Because it's much easier to work with, they can be laser cut to different shapes and sizes, and they can also have some filtering properties like blocking out infrared and passing visible. Optional coatings can also help, again, increase the robustness of that acrylic protection window. AR coatings help to increase the transmission of light. Oleophobic helps to prevent grease and smudges. Hydrophobic coatings can help with condensation buildup. You can see that in this example here, we have one that's coated with oleophobic, one that's not. I'm using a permanent marker there. You can see that the side with the coating cleans off very easily. So think about if you're in an environment that has grease or liquids. You want to be able to clean your system very easily or prevent it from, prevent any issues or marks from appearing on your system. This is a great coating to have. Hydrophobic coatings, they help to reduce the buildup of liquid on there. So you can see the right option that has the coating, the water just beads right off. It doesn't adhere to the surface. Hydrophobic coatings, they help to prevent condensation. So you can see the one on the right, the fog or the condensation is not building up. So again, these coatings, you can take a regular clear window and make them even more useful, make them even more applicable and useful in your different harsh environments. Also, we talked about anti-reflection coatings very briefly. The anti-reflection coatings help to reduce the amount of light that's lost from reflection. When light goes through glass or goes through a material, there's some immediate reflection that happens. You can lose 8 or 10% or more of light that you might need that's very vital for your application. But anti-reflection coatings help to reduce that light that's lost. Take a quick look here. The first filter there, the protective window, has a filter with no coating, no anti-reflection coating. You can see that there's a lot of light that's being reflected. The second one has a mag fluoride single layer coating. It's a very common coating. It's a good coating, but if it's not, it's not the best, depending on your wavelength spectrum. And the last filter, we have a broadband AR multi-layer coating. It looks like there's no filter on there because it's not reflecting that much light. So this is, again, a very useful way to increase the transmission, increase the image quality, reduce the amount of reflections by using anti-reflection coatings. So in summary, filters are essential for lots of things. I was only very briefly able to go over a few of the things that filters are helpful for, but contrast, resolution, repeatability, reducing glare, color correction, and protection are just some of the few. Now, oftentimes I get asked about how do we know which filter to use in our application? The best way is we can, of course, point you in the right direction, but oftentimes you're going to need to test. You're going to need to test with different filters to try and see which gives you the best result. And one of the best tools for that is the machine vision filter test kit that we offer. We offer lots of different kinds of kits with varying filters, but these help you to test in your application to see what's giving you the optimal result. If you want to stop by our booth in Hall 10, F52, we're actually giving a couple of these kits away. They're very expensive, but we'd love to give you one or two. If you come, put your business card in, and we'll draw a name later today and give you one of them. Thank you so much for your attention. Again, my name is Georgie. I'm with Midwest Optical, and if you have any questions about filters, please ask them now or stop by our booth in Hall 10, F52. Thank you so much.
Thank you, Georgie. That was indeed interesting. I would like to give the audience a chance to ask a question if you have asked questions. If you have questions, please feel free to shoot your questions at Georgie. I think he won't mind, right?
No.
Do you have questions in the house? Not yet. If not, then I have a question. What would you say is the biggest challenge in filter technology, for example? What do you say as someone who's an expert at this is the biggest challenge that you face today?
In terms of filters?
Yes, in terms of filters.
One of the biggest challenges I would say is when people disregard filters as an old technology. They prefer to maybe do it in processing or find a solution with software or processing, and trying to convince them that, hey, even though this might be an older technology, we're working on lots of things that's hyper-focused on machine vision to help you get the best high-quality image, create that contrast, offer that protection specifically for machine vision applications that you're not going to be able to get, or you're not going to be able to get as quickly maybe in processing or using some other method. So helping folks understand that is kind of our mission,
yeah.
And showing them that filters are really a necessity.
And how long does an average, when I say average, depending upon the use case, how long does a filter last? What is the lifespan? Yeah,
it depends. The lifespan of the filter, it depends. If it's like a laser application where the filter is constantly being hit by a laser, you might only see a month or, 6 months or a year. But again, it depends on the application. A regular bandpass filter will last 10, 20 years.
Okay.
Because of the type of dense coatings that we use. Mm-hmm. Most likely the glass will break before the filter properties stop working.
And do you also provide services like if your customers send you the filters that they bought from you, yeah, you can still check and say if it's good to go or there's some problems with it? And
we definitely can check that filter. We lot control everything, and so we know exactly what wavelengths those filters are supposed to pass, how that filter is supposed to perform. And even if you're in an application and you need help determining which filter to choose, you can send us your part. We can run some tests for you or let you borrow a filter kit. And we love to be a solution provider and help our customers and potential customers.
Perfect. Thank you so much. That was really interesting. But I will surely get back to you because I have some more questions, but I don't want to take your time on stage.
Sure. Well, thank you again, everybody.